So I'm going to show you now how you can factor a trinomial if your leading coefficient, so A, isn't 1. And the method I'm going to show you is sometimes called the AC method, and I'll show you why. So remember our trinomial, our generic trinomial, right? AX squared plus BX plus C, right? So A is your leading coefficient. It's the number that multiplies the x squared, and C is your constant term. So when we're factoring, remember it's kind of like an unfoil. We're trying to come up with what two binomials would we need to multiply to get to the trinomial that we have. And so if you sort of think about, and I'm just going to write some generic binomial positions here, right? So when you FOIL, right, you have your two first terms multiply together, and typically those lead you to this ax squared. And then your two last terms multiply together, and they give you your c, your constant term, usually. But then there's this combination of your outer, right, so a first one, last two, and then last one, first two, right? Those two have to multiply, and usually they sort of come together and they merge to make that middle bx term. Okay. Now you can come up with this, right, your firsts and your last by some guess check, right? And then you'll either have a pluses or minuses in between here. But there's this method, this AC method, that kind of takes the guesswork out. It's not as, I don't know, maybe not as fun if you like puzzles, but it's one of those kind of like the quadratic formula, if you know that. It's one of those things that just kind of always works, so it's handy. So here's how we do it. So we're going to multiply A times C. So again, A is your leading coefficient, C is your constant term. And then we're going to find a pair of factors for that product, that A times C, and that pair of factors are going to multiply to B. I'm sorry, add to B. Okay? Then we're going to write that BX term as the sum of those factors that we found, and then we'll factor by grouping. And I'm going to use, I don't know if you guys have seen, right, the X before, but I'll put the AC product up top, B goes on bottom, right? And then we're going to come up with that pair of factors that will multiply to give AC and then add to give me B. Once I know what those two are, then what I do is I rewrite that BX term, and then I'm going to do some factor by grouping. So my first example here is 2x squared plus 7x minus 15, and we're supposed to factor that. So I'm going to make my little x over here. So in the top, right, I have 2 times negative 15. So that's negative 30. And then down below, I have positive 7. Okay. So I'm looking for two numbers that will multiply together to give me negative 30, but if I add them, will give me positive 7. So two numbers that'll multiply to give a negative, so that's telling you that one's positive and one's negative. Okay. But then when they add, right, I need to get to a 7. So with all of my talking, has it popped out at you? Okay. So probably it's going to be positive 10 and negative 3. So just check and make sure. Positive 10 times negative 3, negative 30, and 10 minus 3 is 7. Cool. It's okay if you had those in the other direction. It's still going to work, but go ahead and write it my way so that our factors all look the same. And then you can try it the other way, and you'll end up at the same spot. Okay, so here we go. Now we're going to come back up. We're going to write our trinomial, and we're going to tease it apart into 4 terms. So we're going to keep the 2x squared the same. But now instead of writing 7x, I'm going to write a positive 10x and a minus 3x, and then my minus 15. Okay, so that 10x minus 3x, that is just a different way to write the 7x. Okay, now don't combine those because, right, what we're going to do now, this is me looking around for a color. Here we go. We're going to take 4 terms. Right? When we have to factor 4 terms, we do it with the grouping method. So I always put these little square boxes around the bottom, just keep them separate. Within the first 2 terms, you're looking for the greatest common factor. So 2x goes into both 2x squared and 10x. Right, and then we factor it out, so divide it to come up with the remaining factor. So 2x out of 2x squared leaves behind x. 2x out of 10x leaves behind plus 5. Okay, now remember we're going to keep one eye on this x plus 5 when we look to our second group and think, okay, well, what's my greatest common factor? What should I take out? Right, so we would factor out a negative 3 so that I leave behind exactly x plus 5. Okay, so negative 3 out of negative 3x is plus x. Negative 3 out of negative 15 plus 5. So there's that common x plus 5. Go ahead and factor it out. X plus 5. And then the second set of parentheses gets the rest. The 2x minus 3. Okay, so not only, right, we get our 2x squared and we get our negative 15, right, but this is the one and the only version that gets me those, and also, right, the negative 3x plus the 10x to get to the positive 7x. Okay, so let's do it again. So a times c in the top, so 3 times 2 is 6. 7 in the bottom. So now we want to multiply to 6 and add to 7. So since 6 is positive, I know they'll both have the same sign. And since 7 is also positive, I know they'll both be positive. So two positive numbers multiply to 6, add to 7. So 1 and 6, right? So 1 times 6 is 6, and 1 plus 6 is 7. So that's good. So we come over here. We keep the 3x squared the same. The 7x is now going to be 1x plus 6x, and then the plus 2 stays the same, right? So the first one and the last one stay the same. It's just that x term that we expand apart. Now factor by grouping, right? So we're on the last step, factor by grouping. Group, group. So greatest common factor in your first group. So 3x squared plus x, so that has an x common to both. So x out of 3x squared leaves behind 3x. X out of x is plus 1. To your second group, again, keep an eye on, right, the common factor over here. Well, not the common factor, the leftover factors. So if I take out plus 2 from 6x plus 2, it'll leave behind again 3x. Plus 1, awesome, same thing. It only works, factor by grouping only works if those two are the same. Go ahead and factor that out, 3x plus 1. And then the second set gets those common factors that you took out, so x plus 2. If you want to pause and try this last one. Here we go, 6 times 10 is 60. Negative 19 in the bottom. Okay, so now for signs, right? 60 is positive. So the only way we multiply to get a positive is they're both positive or they're both negative. And since the 19 is negative, I know they're both going to be negative numbers. So I'm going to have a negative and a negative here. So two numbers that'll multiply to give me 60. So 60. So if you don't know what they are, right, you can just start writing, right? So you have like 160, 230, 320, 415, 5, 12, 6, 10. I think that's it. Which one of those, right? And they're both going to be negative. So negative, negative, and negative. So all of these will multiply to give me the positive 60. Which one will also add to give me the negative 19? So that would be this pair right here, that negative 4 and negative 15. And again, it doesn't matter which order you write those. Here we go. Back to our question. So 6a squared. Now we're not going to write the minus 19a. We're going to do, right, minus 4a, minus 15a. Remember your a's with those. Plus 10 stays the same. Change my color out. Factor by grouping. So when you group that second set, make sure you grab the negative sign with the 15a. So greatest common factor of 6a squared minus 4a. All right, so they each have an a and they each have a 2. So 2a comes out, leaves behind 3a from the first. You can always check by multiplying, get back. 2a out of negative 4a is minus 2. Okay, so again, kind of keeping an eye on this 3a minus 2. What would I have to take out of negative 15a to leave behind positive 3a? Okay. So if we factor out a negative 5 from negative 15a, that will leave behind positive 3a. Again, quick little check, negative 5 times positive 3, that would get me back. Right? I'm just making sure I can always get back. And then negative 5 out of positive 10 is going to be minus 2. Yay, it is the same. So don't be too, right? You can look, keep your eye over here on the one on the left and say, okay, I hope I can leave that behind. Just make sure you're factoring correctly and not too much wishful factoring. Okay, so it is the same. Yay, go ahead and factor it out. 3a minus 2. And then remember what goes in the second set, right? 2a minus 5. All right, so just so you know, this AC method, it will also work if a happens to be 1. So if your leading coefficient is 1, you can use this AC method just the same. So 1 times, well, except you have to, well, hopefully negative 39. 1 times negative 39 is negative 39. And then 10 goes in the bottom. So the 39 is negative, so I'll have 1 positive and 1 negative. 10's positive. Okay, so I know the bigger number has to be positive, so it wins. So now I'm looking for a pair of numbers that multiply to negative 39. I was there thinking it was prime, but no, 3 does go into it. So 3 goes into that 13 times. Well, that's good. Now, right, since 39 is negative, I know, right, one of these is going to be positive and one will be negative. So then if I think about this 3 and 13, right, which is my pair here, I want the 13 to be the positive and the 3 to be the negative, so that when I add them together, I would get to the positive 10. But they still multiply to give me negative 39. Okay, I have my pair, come back over, x squared stays the same. Instead of 10x, though, I'm going to write minus 3x plus 13x, and then minus 39. And then group. Greatest common factor in your first group is x. What got left behind? Right? X minus 3. Second group, greatest common factor between 13x and negative 39. It's kind of hard to see except for what we were just doing over here, right? So you can factor out the plus 13. And then it leaves behind, right, x minus 3, just like we wanted. There's that common factor that I can't not squiggle under, so factor out the x minus 3. And the other partner is x plus 13.